There are 4 scenarios, 4 cases. I'm going to start by teaching you the cases. So today will be like, this is how you do it, this is how you recognize it. But let me preface it with what exactly you are doing, okay? So, if I gave you a side note, this is not part of the lesson. If I gave you something like that, and I told you to take that and make it one fraction, you have to do what first? Get a common denominator, yeah? Okay, so that's where we're going to start. Okay, so what would my common denominator of this guy be? Do you agree it's x minus 3 times x minus 4? Okay, so how did I take x minus 3 and make it this new denominator? I multiplied it by
X minus 4.
X minus 4, so I do the same thing on the top. So it'd be 1 times x minus 4. And then over here, again, I want the common denominator. And so what do I have to multiply the top by?
X minus 3.
X minus 3. Okay, and then what do I do next to make it, to make it one fraction?
Just combine them.
Combine like terms, clean it up, make it one nice pretty fraction. And then on top I've got x minus 4 plus 2x minus 6. Okay, so I end up with 3x minus 10 over x minus 3 times x minus 4. And you have what we would have learned probably maybe in algebra 1 at the end, maybe, or algebra 2. So are we comfortable with that? Partial, did I see a no? Are we good? We're good. Okay, partial fraction decomposition is given this. How do we get back to this? Okay, so that's what this is. So I'm actually going to do the one that we know, what it looks like at the end, so I can show you the work. What I'm going to show you now is what we refer to as case 1. Okay, so let me say, you don't even know what this is. I'm going to start with 3x minus 10 over x minus 3 times x minus 4. Okay, and let me actually label what case 1 is. So case 1 is going to be px plus q over, it looks awful, ax plus b times cx plus d is equal to a over ax plus b over cx plus d. That's case 1. Are you ever going to have to label case 1 as case 1? Never. You will recognize them as case 1 and then you'll roll with it. But you'll never have to say, ooh, let me label case 1. So it's just a basic, you can tell, what is p and q in this case? It's a 3 and a negative 10. Does that make sense? And what would my ax plus b in this case be? It would be 1x minus 3. And then my cx plus d would be x minus 4. You see where I'm coming from? Okay, so it's from taking something that looks like this, reverting it back to this, no different than I said going from here to here. All right, so how do we do this? Multiple steps that need to happen. First thing, when it's not already factored, in other words, if your denominator was not factored, it was a trinomial, could you unfoil it yourself? Sure. So if this is not in a factored form, you would, step 1, factor it. This guy is already set up for us, so we're good to go, okay? So that might be like, if I did a step 1, if I have to factor, then I do that. If not, now I start, all right? So the first thing I'm going to do is I'm going to equal it to some unknown a over the first denominator plus some unknown b over the second denominator. And our ultimate goal is to figure out what are a and b. So if you were writing steps, you would separate with your denominator, linear factored denominators, and then put a over. If this so happened to have 3 underneath, what would I have here? I'd have a over the first guy, b over the second guy, and can you imagine what the next guy would be? C over the next linear factor. So, I mean, far and few between does that happen, but just in case, okay? All right, so step one, you do that. Now, you're working kind of backwards. So what we need to do is we need to figure out what would the common denominator have been. Okay, so like we need to make this look like the common denominator. So I'm going to rewrite my new denominator for both of them. And what am I going to multiply each of those numerators by in order to make this happen? So for this guy to go from this to this, what would I have to do? Multiply the top by x minus 4. Have I shocked anybody, or are we good? Okay. Over here, what would I have to multiply by? Okay. So literally, if I think about it, I have 3x minus 10 equals x minus 3 times x minus 4, and equals that stuff. All right? So what do we know about fractions when they all have the same denominator, if they're equal to each other? It goes away, right? My denominator goes away. So what am I left with? I'm left with my numerator. I'm left with 3x minus 10 equals a times x minus 4 plus b times x minus 3. They all have the same denominator, so therefore I got rid of it, and I have the numerator equals a times this and b times that. Okay, so ultimately my goal is to get rid of and solve for a, get rid of the other guy and solve for b. So what could I plug in right here that would get rid of a but allow me to solve for b? What value would cause this to just go away for a minute? X be what? Would x be 4? So the first thing I'm going to do is I'm going to let x equal 4. And everywhere I see a 4, I'm going to everywhere I see an x, I'm going to plug in a 4. So I have 3 times 4 minus 10 equals a times 4 minus 4 plus b times 4 minus 3. Are we cool so far? So what do I have going on here? 12 minus 10, which is 2. A times 0, which is got rid of the a. And what do I have over here? B times 1. So what's the value of b? 2. Are we cool? All right, now over here, what's the next guy that I can use for x to be able to solve for a? Let x equals 3, right? How do we see that? It's the thing that will cause this to go away. So we're going to let x equals 3. So 3 times 3 minus 10 equals a times 3 minus 4 plus b times 3 minus 3. I'm just showing the work for today. So you get negative 1 equals negative 1a. And so what's a equal to? 1. And if I go right back to this original, we just decided a is 1. So 1 over x minus 3. And then b was what? 2. 2 over x minus 4. Is that what we should have come up with? Absolutely. What do you think? It's not horrible. It's truly not bad at all, at all, at all, once you start working them. Okay, I'm gonna give you one to try, all right? So, are we cool so far? Case 1 didn't make us too nervous. Okay, so x minus 13 over 2x plus 1 times x minus 3. Okay. What do we do first? Separate it and rewrite it as what? What?
A over 2x plus 1.
Good. B over
X.
Are we feeling good? Okay. Now what? I want to be able to get rid of the denominators, right? So what shall I do?
Common denominator.
Get your common denominator all the way across. So what am I gonna multiply a by?
X minus 3.
Yeah, over x minus 3, basically. I'll do it in a different color so we can see it. And what do I multiply b by?
2x plus 1.
Okay. Sweet. How do we feel? Now that everything has the same denominator, what do?
Cancel.
Get rid of the denominators, right? So I have 2x minus 13 equals a times x minus 3 plus b times 2x plus 1. Cool. Now what do I let x be first?
3.
Let x equal 3. Does everybody see where 3 comes from? Albert, you cool?
Oh yeah, I'm just like,
Soaking
it's
it
my
in.
contacts that are like being iffy today. 'Cause
I got it.
It's a bit out of focus.
I wish I could wear contacts. I can't since chemo. It's weird. Like ever since I did the year and a half, almost 2 years of chemo, I can't wear them. They like instantly dry up in my eyes. So, it's the way it is. All right, how do we feel about that? What'd you get for B? -1? Yeah? Okay, then what are we gonna let x be for the next one? Don't be scared by the fraction.
1/2.
-1/2. Mm-hmm. Does everybody see where I got it? You set it to 0, you subtract 1, divide by 2. Okay. And are you cool with me just putting 0 like in the place of that? Okay, so I'm not losing anybody there. So -1 minus 13 would be -14. -7/2 a. Multiply both sides by -2/7. What'd you get? A is what? 4. And then the last step is to do what? Just rewrite it, right? So your A is 4 over 2x plus 1. And so a lot of people look at the B, it's negative. So you have two options. You can do plus -1 over x minus 3. The way I learned it back in the dark ages is I don't like the plus minus, so I just make this whole thing minus that. But you don't have to do it that way. Now, why in the world am I doing this lesson? Because remember, this is just case 1 out of 4 cases. What if I said, if you fast forward to the next part of our lesson, what if I said take the integral of this guy?
Oh my god.
What would you do? You would be like, no thank you. However, this guy, you agree, is equal to this guy. Does that make sense? And if I said take an integral of that guy, you would say, okay, because I see what?
It's du.
You see du over u situations, like the 4 can come out, we pull out a 1/2, you have du over u, what would you have over here? Also a du over u, pretty easy integration, and then you have a really easy problem. This guy, no go, this guy, we can do. That's why we're doing this, basically. Are we cool? Because Rachel already told me that it's no fun to do any integrals. All right. So, are we cool so far? Case 1. Do you see the different what case 1 is? Case 1 is when you have singleton linears. We're good to go.